Yeah, sorry, give me just a minute. Okay. Yeah, go
So,
ahead.
so the topic we chose was FCM interaction. So both of us, Jyoti Francis and Nandita Indira from Superfabler Kerala. So one of the things that the first day we thought about what are the problems that we have and how we can find a solution. And of the topics, many topics were, where HCM interaction, we had some problem for animals and another for repetitive work, that is where exoskeleton is required. Then we also thought about combining it with art, and there will be an interaction. But then finally, we chose this where an exoskeleton is required, but it is not to help a person to perform something, but rather to help a person to hold his hand against gravity for a continued period of time. And mostly in a case of roofing systems, painting, for a teacher to write on the board, etc. And we decided to work on two designs and pretty much combine these two. One is the first one given there, we actually found it in Google, and the second one is that of a holster, a policeman holding a holster. So we were planning to combine these two, and the end result will be what we'll be sharing. And you can see one walker that Jojin has already designed, which is given there. So the same locking technique that is used there is also used in this prototype as well, which we will explain in detail later. And the second technique we thought of was of soft robotics, which is not in the realm of possibility. Actually, it is in the realm of possibility, but it is not feasible right now to do in a small amount of time. So we decided to go with the first one itself, but then we'll explain what is the second one at the end, which can be which can later be as a later version or something. And the design, I think Jojin would explain better.
Could you please move right, just right? Yeah. So this is actually the design. So the main part of it is a locking mechanism. So where there will be a disk which having a lot of slots, and there will be an electromagnetic actuator which can selectively choose in which slot it wanted to be locked. So there will be a myosensor or a pressure sensor on the hand, so which can detect the intention or the interest of a person, whether it's wanted to be raised up or raised down. From that signal, a microcontroller will choose the right time to disengage the locking mechanism, and when the desired height attained or the user intention is diminished, the locking mechanism will engage on the lock. So we can hold the hand at that particular point. So this is not an actuated joint. It's just a bearing housing. So in the horizontal plane, we don't need any support because we are not working against the gravity. So we can freely move the joints in the horizontal plane, and the locking mechanism will work only on the z-axis. So we were discussing about it, but there are also little more concerns on this also. So some of the issues I assume we'll face is since we are using a discrete kind of method. So if we can't make a fine teeth, so the hand cannot exist in all possible positions. So we are also thinking about replacing the gear with some cables and or hydraulic, so that we can move the actuators and also gas springs or into the back of the body where the larger support is placed, so that we can have a compact component on the moving part, which is the hand, and we can have the heavy actuators and compression springs on the backside, which is not implemented right now, but I have tested a small cable drive mechanism yesterday, and it theoretically it can work, and probably I need to redesign a couple of things in order to change it to that kind of design. So we didn't actually manufacture the joints. We didn't have the opportunity to do it in this limited time. So sorry about that. So I only completed my CAD design, and that's it. Can you continue?
Maybe we want to show the design file.
So you can click on that link and it will open the design.
So in the meanwhile, I want to ask you about how do you think it's the process? What are the learnings from this experience during the challenge?
Sorry, I heard the learning, just the word learning. What we learn? Are you asking what we learned from the challenge?
Yes. So especially what you will think are the learnings personally during this challenge, and also what is the role in for your future user.
Maybe you.
So actually, the design is not much optimized. So this is we just focused on presenting something which could be fabricated in Fab Lab, which means 3D printed or waterjet cutted and some bended metal sheets. So we didn't explore much about other manufacturing possibilities. So the design is not optimized or anything. So while we try do this, we were aware about that it could be optimized. But even though we don't have that opportunities, we couldn't able to do much about optimizing the processes. So, and also we didn't done any testing on a human person or something. So this is more like a theoretical concept, and we are certain about it will work in most of the situations, but we need to further testing, because there are a lot of possibilities that the gears might go jam while there is a load on the hand. So we need to test a lot of things. So there are possibilities, so and there are uncertainties, so which can only be figured out while we were fabricating this. So the fabrication is a very important thing, as well as we try to optimize the design as possible as in the designing phase. But for further iteration, we need more fabrication support, I hope.
And personally, for me, it was about the challenge actually opened up like a world of things that I never thought was actually possible especially, I entered the challenge because when the workshop leader was Adriana, and I always follow her, classes at Textile Academy, and regularly follow the Textile Academy workshops and all that. So, I knew it had something to do with soft robotics, and I'm quite interested in it. So that was the reason, and so basically we divided it into two: the design, and this was Jordan's design, and I was supposed to do the other thing, the soft robotics design, which has not completed yet, but just the idea, the basic design. So, so by doing that is when I actually realized a lot of things. So the workshop actually helped to learn more about it. Or the last 2 days, we might have studied a lot of things, learned a lot of things, and also understood that most of it are things that we already know, but just need to combine these things. So I think that was pretty much my biggest learning.
Thank you, Anita. As I mentioned yesterday, so or also in the workshop of robotics, we are open also in the Fabric Academy to discuss deeper the topics, and also invite you if some of the audience is interested in the course to participate. It's open to apply.
Yeah, I may be joining back this year.
Sorry?
I might be joining back this year, depending on the visa approval. I might be joining back for Textile Academy this year.
Wow, that sounds amazing. Yeah, so we have also an open places in a matrix in case you have interest to come to us. So and also an invitation for the group in a FabCare group. You know that we have opened the website, so to be in touch, and also to know a little bit more about other works in the field of assistive devices and field of the healthcare and inclusivity. Inclusion. Well, thank you so much. I would invite also other people from the group, from the audience, if you want to, if you have a questions, comments for the group.
I actually have a question. Have you had the time to give some thought about how would you incorporate the algorithm to decide whether the sensor data is telling you that the arm is going up and is staying there, or whether, for example, the worker is still trying to fix things in place and would be needing to put the arm up and down? Or have you decided whether you want to do that on time, whether time-based, for example, whether the arm stays up for 3 seconds, then you lock the mechanism? Have you given any thought to that, or do you still have to think about that, or do you have any other solutions of how to do that?
So I actually think about that. As you mentioned, it's actually difficult to understand the interest of the person, because we cannot directly use the pressure values, because if the load on the hand is high, it might trigger the arm in order to unlock and go downward. So that's why I was thinking about incorporating some myosensors also, because if the muscle actually want to move the arm, then only the locks will disengage. So it won't be triggered not because of a huge amount of leverage on the arm because of the tool he is holding. So it should be triggered just because the muscle intentionally wanted to move the arm. So the pressure, if in order to raise the arm, the pressure sensor will be worked, because we are actually manually trying to raise the arm. But in order to move it downward, we need some other mechanism, either using the muscle activity or some capacity or some pressure switches connected to the fingers so that the man can manually turn off the locks, something like that. So I didn't get enough time to figure out a proper strategy to approach it. So it more like an yes or no answer. So I'm sorry about that.
We actually thought about something else as well. Maybe about moving the hand or like couple of just a second for a couple of times, like not moving the entire hand because it's already locked. But then putting the pressure down a couple of times enough so that that's something the system would recognize it or something.
Yeah, so I think that it's especially because the idea in your group grows around, let's say, a problematic that it's not that, as you mentioned, the group that you don't have contact with the user. I think that that would be a very important point that I encourage you to explore further and understand a little bit more about the connection in between the problems around them, so empathize better with them, and after also understand the whole challenge that you have in the biomechanical part. So I think that would be a very important point in order to understand how many forces do you need to take in account, and also other maybe if there is some users that already use an existing system that is similar, can give you like a little bit of feedback. I understand that it's a very, so the time is short, but I am very happy about your results, or I think that all of you did, you at the team did a very nice work. So I just want to have an applause for you. And if there is if there is no more questions, so I will proceed to ask the next group to present the project. Shall I?
Should I proceed?
So, yes, I will give you the rights to present. Just give me a second.
I think I can share my screen.
Yeah. Perfect.
No,
yeah.
No. Host has
right now?
disabled. Are you all able to see my slides?
Yes.
Okay.
Yes.
Basically, at Vigyanashram, we are working on rural development. Okay, so we see the problems faced by the farmers and the laborers who works in the rural areas, and we are empathizing how they feel when they are working in the farm. So we found that exoskeleton is for a small farm and a small farmer, laborer, and craftsmen can be a good option to go with, instead of having a heavy machinery like plowing and working in the farming sector. So we give it a name like Bahubali. Bahubali, it is a famous movie from India, which means person with strong arms. So right now we are working with the shoulder, bicep and shoulder. That's why we gave it a name as a Bahubali, because we are working with Bahu, means hand. Okay. So we identified the need by just visiting to some places where they grow their onions. They seed their onions plant, and they spray the pesticide over the very big area where they have to cultivate, like sugarcane or something like that. Then they need to cut the grass on the roadside. they use the grass cutter, which should be held by their hand, and that weighs around 2.5 kg, just the handle. And okay, that is the from start, that is our aim to solve that issue, because it is very hectic to just grab this handle and cut the grass for let's say 4 and 5 hours continuously, or continuous in a day, and then following it for 4-5 days, then it will be very hectic. So that's why our main target area was that. Then we found another problem, drilling the overhead drilling. That basically is done by the men who work with electricians, who work with drilling for the rooftop. Okay. And this machine we are designing, this exoskeleton we are designing for small farmers, and for the repetitive work. It may not find useful if you want to do one time work, means you have to do just like for 15 minutes work. It may not be helpful for that, but it will be helpful for in the long run. It can prevent the musculoskeletal disorders, which are found in the automotive industry, where they have to do overhead operations like drilling or welding, because the production line is at average height of human, and they have to hold these equipments. Okay. Then as per I said, we empathize the things. How we empathize? We inspect our workplace, how the peoples are working here. So we found that as in the first scenario, Nachiket is trying to do drilling for the for some roof. Okay, then he find that it will be it is creating pain on his bicep and shoulder. Okay. Then here is Ganesh. Ganesh is trying to cut the grass. Then he found that it is the bicep and shoulder which is taking the strain and stress. And here in the third picture, Chaitanya is working. He's harvesting beans, and for that he have to bend. And for like this bending, he cannot work for the 4 to 5 hours. But people at our place, they work for 4 to 5 hours and at least 4 to 5 days continuously. Then in last picture, Ganesh is again, he's trying to plow the land, like something they have to water the farm, and in this case they have to do it repetitively, and it depends how much they want to do. It depends on how much land they have to give the water. Okay. Then our project objective, what we discussed and what we zeroed down to the point, where should we work? We should work on the shoulder, because the shoulder is the main area who is taking all the pain. Bicep is taking the pain, but not as frequently as the shoulder. So by this discussion, we found our objective that we should build a wearable shoulder support system which can assist the shoulder movement for overhead operations. Okay, this is basically for drilling machine, operating a drill for the rooftops, and using the welding machines in the production line. Okay. Then we need to build a passive support system which limits the weight of actuator and power required to drive them. We have to be ensured that while working in the farm, we should not go out of power, because in India you cannot take a batteries with your exoskeleton and work in the farm like that. It will be more it will create more weight than he will work normally. So we try to eliminate that thing, and so we in the ideation session we comes to 4 different solutions that we can apply. That is, one is a spring that might be a spiral spring, that can be a compression spring, or that can be a elastic rope or elastic string. Then second, we can compress the air, and compressed air can also store the strain energy because it is compressed, like in air suspension used in heavy vehicles, like that. But finally, we come. We before that we research about some available solutions, what are available in the market. So we found that Autoblock and Kamau Mate, they both are working in this exoskeleton sector, and but their price is quite high, which cannot be purchased by Indian farmer who have to work in these areas. Okay, this can be afforded by the industry where they pay their employees higher than the farmer can earn. There they can introduce this system. So solution of for lifting weight operation in industry, that we can also target, because every industry is not going to pay around $5,000 on each employee to prevent his musculoskeletal disorders. So a small scale industry can adopt a cheaper version. That's why we are targeting on DIY design for aiding small farmer and craftsmen. Means we just give them a design, and they can manufacture their own springs, and they can assemble their things and get use the exoskeleton. Okay, and then our journey in last 4 days, I think I am explaining this entire in this entire session, this thing. So if you have to look, I can share this file. I cannot. I think I cannot. I should not explain this. This will take more time right now. Okay. But I can broadly I can say in the first day we defined the problem. Actually, we empathize and define the problem. Then we studied available solution. Then we prepared our own designs that are we made actually 4 design, which is one pneumatic based, which is one of spiral spring based, one is compression spring based, and then right, I will show it to you just after this slide. And then after this our challenge, what is our main to go with, that I will explain in the next few slides. Okay. So this is the solution Bahubali we use, and right now we are working just in the shoulder and bicep area, but we are targeting to go with lower back and knees. Okay, but it is later, but just after standardizing our first 2 solutions. Our target is to make the system modular, means we can use the bicep system. If you want to spray the things, if you don't need a shoulder system, you should eliminate that thing. You can use the shoulder system when you are lifting some kind of tables or heavy things. Okay, you can use the both combinedly when you are drilling something. Okay, and like that, each module is can be used independently and can be used with combination with each other. That is our main aim. Okay, then how we build it. Here is our fabrication team. Just yesterday night we spent a long hours to fabricate this all things. Here I can show you the sketch at the middle of the our poster that we are working on. On the right side, these 2 designs, they are made by Nachiket. Nachiket was working on spiral spring, and we found it is more easy to implement because we have the spiral spring in our hand. We don't have pneumatic cylinders and compression springs and that artificial muscle things in our hand. So we can fabricate this thing, and we go with this system. Then what will be the future of this system? Features of this system. This system can produce assistive force for overhead operation. Okay, this will not take entire load, but just assist. How much it assists? Current prototype produces 3 kg of supported force. We did not calculate that. It was the just like proof of concept thing, but we tested it, and it produces 3 kg of supportive force for the shoulder joint. Okay, and current weight of the system is 0.816, means approximately 900 grams. So it is giving us 3 times more the force we are lifting. Okay, that is the data we have collected. I can show you few videos right now. Okay, how we are working. So how we use the mural chart. We are not familiar. We were not familiar with this chart. We use this for the first time. And this is the empathize stage where we find out the pain areas. This is our first prototype, means when we don't have metals to work with, then this is for the bicep that we did earlier. This is Nachiket working with his modeling things. This was our design when we Okay. Currently, they have tied a wire to support this. This was just in morning. At morning they tied, but right now we printed a 3D object to hold the bicep. That is not perfect. That is sleeping sometimes, and I can show you how this thing can be wearable. And this is the backside view. Okay. So next slide. This is our model. Work remaining to do. What we target to do. We try to make it more aesthetic, more user friendly. Selection of material is remaining. We did not selected the material. We used whatever we can found. Lateral movement means the connection between back and the rod which is connecting the support at the back, and safety and the user convenience that we have to find out right now. Then here is our team. I think I forgot to mention our sir, Mr. Dr. Yogesh Kulkarni sir. He was the one to motivate us to just to take part in this challenge. We were working on the exoskeleton, but we did not know that this challenge is going on here. So thanks to him too. And this is our team. That's it. Thank you. If anyone wants to ask something, and if anyone wants to see the model, I can show. If anyone wants, then.
Yeah, thank you to the group. Very interesting process, and as you said, that it's interesting that you could reflect through this week around the process of making this assistive device for activities in agriculture. So I would like to see if there is if there are some questions around the group. comments or suggestions? I mean, if anyone wants to talk, but please go ahead if you want. I have in the meanwhile a question, and it's about what do you think that it would be directly the next step if you need to use the system? How you think you could adapt this? And second, yeah. So first, please.
Sorry, you just asked me something.
Yeah, so I have a question, and it's about what would be the next directly step that you need to adapt for your system if you need
Okay.
to wear it.
Okay. If I need to wear it, I currently I require two people to support this and while wearing. So it should be user friendly. One man who wants to work it should be able to wear it easily, and then one part the back structure, which is one pipe which is just floating around. There we did not use the ball socket joint. We need a ball socket joint, but we did not have it in our hand. So it is giving extra degree of freedom to that rod. It is just because we don't have that in our hand. We just screwed that thing and made a bigger hole. That thing need to improve. And there are various aesthetic issues which should be considered if we are going to implement this uh, with the user. I think our next step will be we are going to give this equipment at the at Vijnan Ashram. The persons who are working in the spraying, in grass cutting. Actually, we have the persons who actually I work with the drilling operations. So I can also use that thing and experience how this thing is works for me. And then according to that user feedback or myself feedback, because I am also using it. So according to my feedback, we can improve the system step by step.
Yeah, thank you so much. There some other comments? So I just see in the chat a lot of like congratulations for you, for the team. So another question that I have is about the replicability in the Fab Labs. How did you have some thoughts about this topic?
Yes, this model is replicable because we did not use any specific material found in somewhere. The spiral springs, the pipes we used. When we have to design it for say particular types of people. Like if we are designing for European peoples, if they are some their height and weight, that things should be matched, then it can be useful for them too. If then our we thought about making three sizes, like small, medium and large. And then we can I think we should cover the most of the population to wear this thing. And then at every fab lab this can be easily replicatable. But if they did not find, if they want to make it like a product, then they need some specific equipment like welding and drilling machine. That is a heavy drilling machine which works on metal, not the machine which works on wood or 3D printer. That are the things they will require if they want to build a product and to use and test it. But if they want just a prototype, just proof of concept to do, then they can work with acrylic, and so it can be replicatable for at any fab lab.
I have one last question.
Please.
Do you think this project would be also useful for smaller body parts, for example, hands, or can you attach it to fingers as well, or does it need to be big? How do your springs, for
Okay.
example, behave if you want to attach it to smaller body parts or to bigger body parts if you want to support the whole back or the whole thigh size of the body?
Yes, I thought I have seen this somewhere. When the programmer, some programmer continuously typing, his fingers get fatigued, and so I found some product which just a elastic band type which they wear on their finger, and they can be used there, but right now we are working for the farmers for in the rural development. For that we are focused on in this area, but we can implement that thing too. It is not very complex. It is just making the larger system to the smaller scale and changing the material, like instead of using spring, we should use the elastic bands and this.
Okay, brother, and the whole group, as I find an amazing job what you are doing in this week, and I hope that you continue the idea. And I want also to say bravo. So
Thank you.
congratulations also to the team. Yeah, so if there is not further questions, we need to, the session actually was planned just only for 1 hour. I thanked all of the participants for this session, and I invite you to make a picture of the group. So if you can stop to share the screen, and maybe we can do the people who want to be in the picture, so we can just do this. And after we will discuss the results in group. So I was just at the very beginning, the announcements were planned to be at in half hour, but they moved this, the announcements of the winner or the group, and also as I mentioned yesterday, especially for the participants, that it will be a short announcement in the Fab word. So with some of your ideas, so that would be at 11:30 EDT. So just it means also 2 hours more. So just be online, and I hope that I wish you all the best for both groups. Okay, so then if, as I said, if you stop to share the script, we can just do shortly a group picture. So so I just want to do this. So for the ones that want, of course, to be in the picture, please could you turn on the camera? Wow. Okie dokie, thank you so much, and also thank you for joining this session. So thank you. And yeah, see you in the announcement. The announcements will be not from us, it will be from the foundation. So just be in touch, and you have our emails. So we can also be in touch via the Slack channel is still open. But in any case, you have, we can also post, I will post our email here. So in a sense, if you need any, we can also keep in touch. And with especially thank you also for all the team that also support this challenge, and the wonderful job of Lynn, Peter, Paula, Alexandra, Ahmed, that is unfortunately not here, Niels, yeah, and Enrico for being this process, and thank you so much for all your efforts. As I said, I wish you best luck, and yeah, so see you in the next, for the others in any case, so for next year, next challenge.
Yes, sure.
Bye.
Thanks. Bye.